We'll organize the important proposition in inner product and orthogonality. Inner product is when U and V are in R in same Rn ambient space, then we will transpose one vector and we will um, multiply each of the component and sum up it. So when U and V and W is a vectors are vectors in ambient space Rn, then there's some property we can prove, which is U dot V equals to same with V dot U, and U plus V and W's dot product is same with U dot W plus V dot W, which is law of distribution is possible. And also when you do scalar multiplication, you can also do C U dot V is equal, and also CV dot U is also equal. And U dot V, U dot U should be equal or same with 0. And U dot U is 0 only if and only if U itself is 0, which means the length of vector U is 0. If we keep going. And there can be problem, which is you should find a unit vector U, which is in the same direction as U. Unit vector is a vector which has same direction, but the magnitude is different because its magnitude becomes 1 when it sum up its when it when it sum up its value, it will become 0. And when it sum up its like its fraction, when you sum up the upper part, then it should be same with the below one. So it will be 1. So, so- wait a minute. I think I explained wrongly. Mm. And you can also define distance. Mm. Uh, how can you find the unit vector u in the same direction as u? What is the most simplest way to remember it? Mm. Would be the most easiest way to remember how can we calculate unit vector. Um, if you calculate the length of the vector, you can calculate it by uh, multiply itself and sum of everything and divide it. That is, and divide each of the vector entry by the by the root or root by the length. Length will be, how can we get the length? It will be root or square root of v dot v is the length. Okay. And there's very important concept which is orthogonal vector comma. There is perpendicular, there is orthogonal, there is orthonormal, which is all important concept. I will go from orthogonal vector. Consider there is R2 or R3 and two lines to the origin determined by vector u and v. Let's think about the vector length of vector, which is u minus v. And let's think about another vector length, which is u minus v. Then they are actually same. Then we can calculate the distance between u and minus v, which will be, you already know the length formula, which will be minus each other. And that product it, then you can actually find the similar result, which will be u squared plus v squared plus 2uv, and another thing will be u squared plus v squared minus 2uv. They will be equal when u dot v equals to 0. U dot v equals to 0, we will, and they become equal, the distance become equal, we will say they are orthogonal, which means they have 0 property, they have 0 common distance, they have 0 common length each other. So if they are two vectors, they have this kind of same length, but if it moves like this, then same length will be decreased. And when it becomes orthogonal, they have 0 same length. What if in negative case, they have -1 of same direction? And we will also look for orthogonal complement, which is if a vector G is orthogonal to every vector in a subspace W of Rn, then G is said to be orthogonal to W. The set of all vectors G that are orthogonal to W is called the orthogonal complement of W and is denoted by WT. There's related with theorem, which is a vector X is in WT if and only if X is orthogonal to every vector in a set that spans W. WT is a subspace of Rn, which is, it has an element and it is in Rn. The ambient space is Rn. Let A be n by n matrix. The orthogonal complement of the row space of A is the null space of A, and the orthogonal complement of column space of A is the null space of A. And there's also a formula came out you usually studied in high school, which is u dot v is actually, you can calculate by length of u and length of v multiply length of v and the cosine theta, which is the angle between them. This notion is similar concept with R squared in statistics. It also defines the angle in between two vectors. You can induce it by law of cosine. And there will be orthogonal set if each pair of distinct vector from the set is orthogonal. For each pair, that if we do every pair, if we do inner product for every pair of vectors, if it is 0, then we will say it is orthogonal set. And orthogonal basis always came up. If we go deeper later, we will look for why basis is always exists. It is, we can prove it by some lemma. The orthogonal basis definition of orthogonal basis is for subspace W of Rn is a basis for W that is also an orthogonal set. Let we learned about orthogonal set, which is every pair of each vector. If we do inner product them, the value will be 0. And let's say you want to be on orthogonal basis for subspace W Rn. For each y in y, W, the weight in the linear combination will be given by Cj equals to Uj dot Uj. And the upper part will be y dot Uj. And you can do orthogonal prediction, which will be kind of related. It's very similar picture with linear regression. You can find it by y hat is y dot u over u dot u, which is you use orthogonal basis. So let's say let y and vector, which is in R2, you can find orthogonal projection of y onto u. It will be, you should first compute y dot u, and you should compute u dot u. Then you can get y hat. And you can also calculate y minus y hat. If you calculate y hat, then y hat and y minus y hat will be orthogonal. You can check it. And there's orthonormal set. Orthonormal set is if an orthonormal set of unit vector is exists, then it is orthonormal, which is orthogonal plus they are unit vector. If W is the subspace spanned by such a set, then U1 to UP is an orthonormal basis for W, since the set is automatically linearly independent. The simplest example of an orthonormal set is a standard basis for Rn. They are orthogonal and they are also normalized vector. So if you want to check is it orthonormal, then you should do first inner product of it, then it will be 0. Then you can also check is it unit vector, which is that product they are self, then it should be 1. Then it will be also it will be normal vector. And there is orthogonal projection and interesting concepts come out, which is very important in linear algebra and data science, the Graham-Schmidt and linear least square problem, where we will do it next time. See you again.